So page 22, or that second booklet. All right. So let's recall a few things. Data is normally distributed if the following are true, right? Obviously, 100% of the data is under the curve. No news there. The graph will be symmetric. It'll be half and half. And the mean will be like the middle. Most of the data points will be around the middle, which is saying right here, mean is at the center. Half the values are below, half of them are above. It follows, this is big here. This is what we're gonna focus on to prove it, because we're gonna look at the graph and we're gonna be like, yeah, it kind of does look like it. It does look like it, so we're close. But this is what we're really gonna focus on today. Does it follow that rule? Okay. The mean, median, mode are equal or are close to each other. That's another kind of, these are all indicators that we're looking at a normally distributed data set, but not all data is normally distributed. Like, we've been dealing with a lot of examples where it is the case, but we have to analyze it and check. So here it is, the state whether or not the data is normally distributed. Right? So this is not perfect. I purposely picked instances where it's not perfect, but if you just try to connect the tops, right? Like if you go and find the midpoints of these bars, right? And if you were to connect them, and you don't need to make it look all that good, but connecting the midpoints tells you already that, you know, does this look symmetric, right? The data that occurs most often is here. So my average should be somewhere on the higher end. But you can clearly tell that it's not symmetric, right? So I will pick on this one first. Graph is not symmetric around the mean. Okay. And then we would conclude, so visually, we can conclude that the data is not normally distributed. And so what does that mean? We cannot use normal CDF to predict where values could land. We cannot do that because it doesn't follow all of the properties that would accompany normally distributed data. Okay. So let's try this one on the left. If you were to, and remember, this is not perfect, right? So remember, you go like this. And I will say, although the graph does not have perfect symmetry, it appears to look like a bell curve. we would have to see if it follows the 68, 95, 99.7 rule. So to be certain, we can't just go by the graph here because it's not perfectly symmetrical. But if it follows the 68, 95, 99.7 rule, then we would still qualify it as normally distributed. And I want to tell you that these are former grade 11 test scores from different units. It's not this class. I promise it's not this class. This is a couple of years ago. I just went through and it's like, that's interesting, right? Like some years, right? Like this particular unit test looked like it was normally distributed, and then another test did, right? So what went wrong there? Obviously, you could dive in deeper and analyze what went wrong. It was one maybe pre-COVID, one is post-COVID. I don't know, right? Was one virtually, the other one in person? We don't know. That's totally beyond the scope of today's lesson. Okay, we don't go that far. So let's go into the steps. Let's go into the steps on how we will proceed. Okay, so this is where you need to, I'm going to make a slight change because I worked through these questions and I want to make it easy for you. Okay, so here it is. The first step is always determine the mean and the standard deviation. Right, mean and standard deviation, of course. Sort the data if it's possible, and most of the time for us it is. We have a calculator that helps us do that. And then I'll say draw a line, right? Label a center with the mean, then go up by 4 standard deviations and down by 4 standard deviations. I'm not going to highlight all of that, but then next is create a frequency table using the standard deviation as the interval width. That's new here. We're going to use the standard deviation as our interval width. So it takes a lot of the guesswork out of it. Remember, it was like, what should I use as my width? Now I'm telling you, whatever the standard deviation is, that is what we're going to go up and down by. Use the line in step 2 to help you do this, okay? But I'm going to tell you to scratch the frequency table. The textbook asks you to do that, but I'm going to say we're not going to do frequency table. We're going to make a frequency line. Okay, frequency line. That's what I want you to focus on. Are you going to remember that? When the textbook says make a frequency table, or my worksheets, you're going to make a frequency line. Okay. Step 4, graph a histogram or frequency polygon using the frequency line in step 3. Does it look like a bell curve? You're going to ask yourself that at that point. Okay. 5, check if data follows the 68, 95, 99.7 rule. That's the empirical rule. So check to see if 68% of data falls within 1 standard deviation, if 95% is within 2 standard deviations, and 99 within 3. And this is important. If data is off, right? If data is off by more than 5%, we say that it does not follow the rule. Okay. So, for example, I'll give you a quick example here. Let's say you check and you figure out, within 1 standard deviation is 70, then it's 96. Oh, sorry. Let's make this more aggressive. 78%. Sorry. Let's say the first is 78, 96, and then it's 99%. If you compare it to, right, what it's supposed to be, right? If you compared what it's supposed to be, this one fails, right? Like you check that it's 78 and it ended up, right, being way past the 68 mark. So if it's off by more than 5, we would say it does not follow. Okay? Because remember, this is not going to be perfect. It's just going to be approximating. Okay? Let's go and try an example. $23. Enter that, please, into the calculator. I'll give you a heads up there. So go ahead and enter that, and then I will come back and start that. Okay? Actually, not just that, but determine the mean, median, mode, and standard deviation of this data set already. So you go ahead and do that. I know you're able to. This is what I get. So I would go one variable stats, right? And my average, 102.5. Is that what you got? I have a thumbs up, a couple of nods. Okay, good. I don't want to continue if I got that wrong. Median is 99. Still good. And then the mode. The mode, for me, there are 3 modes. I don't know if you caught that, but you should go sort in ascending order, right, for L1 to do this one. And if you go through it, you have 89, 99, and 100 minutes. I don't know if you caught that. All of them appear 4 times. So they're kind of tied for mode. Okay. And then your standard deviation, I'm going to do that right here. My standard deviation is 24.73. Make sure you round to 2 decimals, okay? And I didn't ask for it, but I always check. Like we're talking 50 is my sample size, 50 movies that are being considered. So now I kind of have everything I need. I'm kind of going to box that in. I don't need you to necessarily find the mode and all of that, but definitely, right, you want to focus on the mean and the standard deviation, right? Like that's for determining whether or not things are not normally distributed. Those 2 are the ones you want to focus in on. Create a frequency table using standard deviation as the interval width. I want you to highlight that, right? Because we're going to use the standard deviation as our interval width. That is somewhat new. And so I'm going to go B here. Create a frequency line instead. This is just for practical purposes. This is a lot better than doing the frequency table. Frequency table takes so much time, and on a test, you're not going to have that much time. So grab your ruler, leave a little bit of space, and so I'm just going to make a line like that. I'm going to determine where my middle is going to be. It's right there. And then I go out. It's ideal to go out 4. So if this is your mean, then it's 1, 2, 3, 4. And 4 to the left. I kind of crammed it a little bit, but that's okay. It will still work. So my mean is down in the middle, and then it's 102.5. You don't need to put minutes down, to be honest. This does not have to be pretty, okay? But I put the middle value in there. I'm thinking a little bit. I'm looking at my space here. Yeah, it'll be fine. And then you just go up by the standard deviation. So you have to, I would strongly suggest you grab your calculator and then you go to your home screen. So you go 102.5. You have to be accurate here. So you go plus 24.73. Right? You take a standard deviation added to this. And so this is 127.23. And then the next one is, I'm going to add another standard deviation to it, 151.96. And then the next one, I add another standard deviation to it, 176.69 plus 24.73 again. And that's I'm going to extend that line. That's 201.42. I'm going to zoom in a little bit because I haven't used the whole. Okay. And then I go to the left and I subtract a standard deviation from it. But because you're going to look at these notes a couple of weeks from now or days, I would say here, start here. You start there and then you just, right, you just add a standard deviation every time, plus a standard deviation, plus a standard deviation, right? So that's what you keep on doing as to come up with the other values. And then you subtract, right? You go back to the middle. I go 102.5 minus 2473. And that's 77.77. And then I extend a little bit. So I subtract another standard deviation from it. And that's 5304 minus 24.73. That's 28. These numbers are going to be very important. So make sure you get them right. And then my next one here, I subtract another standard. If you go into the negatives, that's fine. Don't worry about it too much. It happens. Okay. But that's what I get. So here I go minus, right? To get that, I went minus a standard deviation, and then I went minus another standard deviation, and so forth. Right, so every time I went to the left, I did that. And then you want to go and just make little bins. We're going to put the numbers in those bins. Okay. We're going to put the numbers in there. Why am I going 4 in each direction, you might think? Because there are chances that something goes in a bin that's like outside, like they're so small or so big, they're outliers, and you want to have a bin for those outliers. Now, this is the more time-consuming part. Grab your calculator, and let's see if I can fit everything on there. You go to your L1 or wherever you put this in. My L1 is already sorted. Got it? And my first value is 25. Where would that go into? Which bin? It go in between here, so I put a mark down. Right? And then you have 73. Where does that go in? That would actually go here, correct? So this stays empty. And then the 73 goes in here because it's between 53 and 77. Does that make sense? And then I remember the 77. The next number is 78. That would already go into this bin because it's bigger than 77.7. So the 78 goes in here. And now I remember, what's my next cutoff line? 102, right? You follow? 102. So I'm just going to count now. 78 is already in here, so I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. That still counts, right? 34, 35. Oh, that 103 is past the 102, so 34 it is. So I just put down 34, just write it in here, 34. If it's that big of a number, I just count them and I put them in there. So the 103, when I get to 103 on my calculator, that's already in this bin. So I'm going to count until I get to the 127 mark, okay? So I count 103, 1, 2, 3, 4, 5, 6, 7. Oh, I can't count that one into the bin, so I have 7. Let me double check. 103 it started, right? So 1, 2, 3, 4, 5, 6, 7. Yeah, so that was 7. Go in here. And then I keep going. 129 is in the next bin. So 1, 2, 3. Oh, that's 154. That's already passed. The 154 would go in the next. So I have 3 in here. And then 154. I start counting at 154. So 1, 2, 3. I have 3 there as well. And then 180 goes in this bin. And that's the last number that you have. So you can just go 1 here. I could have actually done that with all of them. Just count how many go in there. Instead of making marks, that's just way too time consuming. Okay. So you've placed, right? I will put a note. Place all points in its bin, right? That's what you want to do. You want to place all the points in the bin that it belongs to. Okay. And now we're going to graph. See? Graph. I'm going to go histogram because you can always make a frequency polygon afterwards. So grab your ruler. And just make one of these. And you just want to make sure you have enough room to fit that in. How many spaces would you want? Count up here, watch. You count with the first one. 1, 2, right? So you start here, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9 marks. Okay? So I'm going to start here. 1, 2, 3, 4, 5, 7, 8, 9. So that's good enough. It works for me. What are we talking about again? What are these numbers that we've collected? Movie lengths, right? Okay, length in minutes. Okay, just have something there. It doesn't have to be movie lengths, but right, like we're talking length in minutes. And what would go up the y-axis? Movies, right? That's another good question. How many hours do you spend on Netflix? All right, so I go zipper. I insert that zipper. That ensures that I will get no deductions for just starting with my first value here. So I go 3.58, 28, you copy basically. 53.04, 77.77, 102.5. I'm going to go like this, 127.23, and 151.96, 76.69, and 201.42. I will most likely give you a grid on the test, right? So it's a little bit easier. But maybe just be prepared to do it from scratch. And I look at what frequency I need. If you go up here, my frequency line, I need to make room for 34. So I'm going to think of it like this. I'm going to go, if this is 10, 20, 30, that'll probably work for me. So 10, 20, 30, 40, right? There it is. And then you make your histogram. So there's one movie between 3.58 and 28.31. Right, there's one movie there. Nothing between 28, 31, and 53. Then there's one again in the next category. And then you have between 77 and 102, there's 34. I'm going to use a ruler for that one. $34, and then 7, and then 3, 3, 1. What do you think? Does this look like a bell curve, like a smooth bell curve, symmetric? It doesn't taper off even, right? It just goes straight up and then down. So you kind of have your suspicion. You're like, I don't know about this one, right? But you can't conclude just yet. Okay. So here's D. Leave yourself some space here. You know what? I would like to do it here, but I left you space on the other side, or no? No, I see it that it's okay. Never mind. So I will do it here. D. This is what you need to check, folks. Got it? I hope if you're doing the graph, just follow this right now. I'm going to leave it up there for you to complete the graph. What you need to check is plus or minus 1 standard deviation. What percentage lies within 1 standard deviation? The rule says 68%, right? We're going to check. So you go arrow like this, and you need to know that how many movies are we talking about? We're talking 50 movies. How many are actually within 1 standard deviation? You go here, this is your average right here. Put a little average sign right there. The 102 is what you want to focus in on. Okay, how many movies are we talking about? 34 and 7, right? Because you got to go to the left of it and you add 34. You go to the right of it, you add the 7. So we have, that's 41, right? 41 out of 50. And calculate that as a percentage. Go ahead and do that because I don't know. I feel like some of you need to just wake up a little bit. 41 divided by 50, right? Times 100, that's 82%. And then you go versus 68%. That's what we're supposed to, that's what we're comparing it to. And it fails, right? So this one, it fails. Okay. Let's check plus or minus 2 standard deviations. It's still out of 50. And so you go 2 standard deviations to the right and you go 2 to the left. So it's 1 plus 34 plus 7 plus the 3. So that gives you 45 out of 50. And that is 90%. Oh boy. Versus what? What's the second number? We're comparing it to 95, right? Did I say more than 5% off fails? Or yeah? So this is technically still good. I would consider that okay still. And then plus or minus 3 standard deviations. Okay, follow me here, folks. Where's my pencil? It's where the mean is, right? So I need another pencil. So you go 1, 2, 3 standard deviations to the right. So you need to add up all these values here, right? 1, 2, 3. So it's 35. It's basically everything because if you think about it, 1, 2, 3, right? This way, and 1, 2, 3 this way. There's only these two on the extremes that are not included. So we can just say that it's 48 out of 50. And that is 96% versus 99.7. The last one is almost always going to work out for you. But because it fails, you're going to be upset at me. Once it fails, you can actually stop. Like as soon as it fails, you stop. But I wanted you to see the rest, or else you wouldn't see the rest, right? But it fails here because it's off by more than 5%. So I wanted you to see one that doesn't work before you see one that does work. Because most of the time, most examples, I must say, do end up being normally distributed. That's the ones that you're going to see. Okay. So we made our frequency line. We used that frequency line to make a histogram. We were already doubtful that this was going to be, but we confirmed it by doing this. So here's the concluding statement. Where in the world are we going to fit that? That's the problem when you make your booklet and data is not, emphasis on the not, normally distributed. Since it does not follow the 68, 95, 99.7 rule. What is it called? The empirical rule. Okay, so I will make like a cloud around that statement. Data is not normally distributed, and the length in minutes found its way in there as well. Oops. But it's not, that's your final concluding statement, right? Don't just stop here. Don't just stop there. Like, just make a little statement. It's not because it does not follow that rule. Okay. Okay. In the interest of time, okay, I will not go. I have a crazier one on the backside with popcorn. Believe it or not, popcorn is normally distributed. Like it goes pop, 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 pop. Right, most of them pop in the middle, and then some will take a little longer to pop. So there's something to take home, right? take it outside. Okay. Backside, I will skip the popcorn question. And I will take you to page 25. It says it right there. Determine the mean and the standard deviation without using the TI. Okay? This method is used when you're given limited information about the data set. If only two values are given, the question will often mention the percentage of values located between them. Okay. If it mentions 68%, right? If 68%, you should know, right, that the data points fall between the values. We know that it is plus or minus 1 standard deviation, so there will be 2 gaps in between. Think about it here. You have minus 1 and plus 1. If you think about those values, there are 2 gaps in between them. Okay. If it mentions that 95% of data points fall between the values, right? If it's 95%, you should know that it's plus or minus 2 standard deviations. So how many gaps will be in between those two values? 4 gaps. Because if you think about it, -2 and +2, if you count the number of gaps in between them, there are 4 gaps, 4 standard deviations. And then the last one, 99.7, which is the majority. When the question says the majority of values fall between, then it's plus or minus 3 standard deviations. And notice that you just double that number, the 3 times 2, so there will be 6 gaps because you go 3 to either side of the mean. So I just want to re-emphasize that for what we're about to do here. And here it is. So this is just there to remind you of the bell curve. We can use the following formulas. So watch this. Very important to calculate the mean, right? We just use this one. We take the upper value and the lower value and we divide it by 2. Okay? Maybe I will emphasize that this is a plus situation, like you're going to add them. You're going to add them and then divide it by 2. If you want to calculate the standard deviation, if it's asking you to find the standard deviation, we use this one. Okay, and it's upper minus the lower. So I make the distinction with the other highlighter. It's minus the lower divided by the number of gaps between the values. So make sure these are on your study sheet, okay? So this is not to be used, right? Don't use it if I give you a whole bunch of values and you're supposed to enter them all and find the mean. You don't do that. This is when they give you 2 values and they will make reference to these percentages in particular. That's when you use these guys, okay? So number of gaps will determine what the percentages are that they mention. ready? Let's use them. Page 26. A farmer fills bags of potatoes in order to ship them to the local market. After weighing all the bags, he finds that, oh, that should stick out like a sore thumb. 95% of bags, right, weigh between this and this. Lo and behold, this is what I call lower, and this is what I refer to as the upper. So you're given two values. That's like the range of values that will have 95% of bags between them, or comprised in that. Okay. Assume the distribution is right. We're assuming that it's a normal distribution, of course. State the mean weight of the bags. So let's go here. Okay. How else would you find the mean, right? Like you just think about it. You just have two values and 95%. Like how else would you find that, right? So in this case, you just go upper plus lower. You just divide that answer by 2. And you know what? I should do this because some students forget that there are invisible brackets. Whenever you have a fraction and there's stuff happening between numbers up there, you need to do that first before you divide by 2. And so I go 65.6 plus 56.4 divided by 2. Pretty sure that's 122 divided by 2. And so the average is 61 kilograms. And determine the standard deviation of the weights. To find a standard deviation, we take upper minus lower divided by number of gaps, not 2, all right? It's not divided by 2 when it's the standard deviation. How many gaps are there? 95% tells us that it's plus or minus 2 standard deviations, so 4 gaps. Cuatro, right? Some of you know what that is. 4 gaps, right? So we go divide by gaps. So we go 65.6 minus 56.4 divided by 4. There are 4 gaps. If it had been 68%, then it would have been 2, right? So let's go 65.6 minus 56.4, 9.2 that is, divided by 4. That's 2.3 kilograms. You should be able to test this. You should be able to do that. So this should be, figure out that this is 61. So this would be 63.3. And this would be 65.6. Right? If you go 2 standard deviations to the right, I just pulled this one up, right? And this would be 61 minus 2, that would be 59, so 58.7. And this would be 4 and 56.4, which I predicted, right? So if you think about it, if you took the standard deviation and you subtracted it twice, you get to the first value you were given, that lower value. And if you add a standard deviation to that, okay, twice, you get to the upper value that I was giving you, right? And how did we find the average? We added these two and divided it by 2 to get the middle. So we're basically finding the middle value. So you should be able to confirm that. And let's do C and D. I had another question there, but I will leave it at that. Talking too much. What percentage of bags weigh less than 57 kilograms or more than 65 kilograms? You didn't graph anything, right? So I'm go normal CDF right away. What percentage of bags, right? So normal CDF. You want the ones that weigh less than 57 or more than that. So what I'm going to do is I'm going to figure out the percentage of bags that weigh between this, and I'm going to use my new mean and my new standard deviation that I just figured out. But I'm not going to multiply it by 100 because I'm not quite done yet. Okay, so I'm going to go normal CDF, 57, 65, 61, 2.3. Make sure you try this. So you have 0.91, that rounds to 80, right? These would be between, right? Between 57 and 65, right? That's what I just found. But I want everything that's less or above, right? So let's make a little curve here. This is 57 and this is 65, right? In here you have 0.9180. That's what you just found. You found this. But the question is interested in these, like these two combined. Like what would those two be combined, right? So the answer is 1 minus, so 100% is the whole curve. We're going to subtract the 0.980 from it. Wait a minute. Yeah, sorry. No, I thought I made a mistake there. So we're all good. That's 0.0820, like that, if you want it. If you multiply that by 100, you get 8.20%. That is the answer, right? So I found what it is in between. I subtract that from 100 or from 1 because I kept it as a decimal. And so this is the answer to that question. How many bags would that be for D? Well, I'm talking 785 bags. We multiply that by 0.082, right? So that's how many bags we're going to remove. 64.37, which is approximately, what would you do there? Would you round up or down? I would round it up, right? But if you round it to 64, I'm fine. This is the instance where you want to round. When I'm asking you how many tires, how many bags, how many babies, how many patients, how many movies, then you round. But if I'm asking you to find the average or standard deviation, do not round, okay? Those are the ones we don't round. Oh, E. Okay, let's do E now. I have another question under there, so I'm just going to keep my piece of loose leaf on there. E. Give it a try right now. Everybody by themselves. Give it a try. How would you answer that? What weight would result in 55% of the bags weighing less than it? You know how else you can rephrase that? If this helps you, I would say 55% of bags weigh less than question, right? That's what the question is asking. Maybe if you want to rephrase it, 55% of bags weigh less than it, which is that weight you're after. Yeah, okay. Oh, was recording this whole time. Okay. I need to use inverse norm, right? It's not percentage of bags, it's like actual score, actual value it wants. But I need to figure out, is it 0.55 or is it 0.45? That's always the question. Can I tell you something? If it's worth 2 marks, you're probably gonna have to do some extra work, right? If the question is worth 2 marks, it's probably not just gonna be 55%. So let's do this on the side here. 55% weigh less than this weight. So if you think of the middle, you have 50-50. If you consider this, which is your average, 50 would weigh less. So you want to be a little bit further to the right, where the 55 goes here. Okay? Because if you're here, 55% of bags weigh less than this weight that you're after, right? You don't seem convinced. What weight would result in 55% of the bags weighing less than it? So you have to consider that you're over here because you have most values weighing less than it. So this is 45, right? So if you used 45, I'm sorry to tell you that it's 0.55 in this case. So then you go 61, comma 2.3, and that's why I wanted you to practice, right? Because it's somewhat critical for you to get that. And let me just go ahead and do that myself. 61, comma 2.3. 61.29. And what is my answer is in kilograms. All right. So I can leave it like that for sure, right? I want you to keep it like that anyways. So this is the weight that would have 55% of bags weighing less than it. Right? Otherwise, I would have had to say, what's the weight where 45% of bags are heavier than it, right? Then you would have to do the math and figure out the percentage of bags to the left and plug that in here. That's always the important part. Okay. All right. I had another question for you. How is your space? You have like this much space in there? Oh, let's use the back. So if you flip towards the back, anywhere, any blank space, don't use the test checklist. Just go past that. And I want you to copy this question down. Because this is a curveball. Karan is our did he win provincials badminton? Yeah. So used his name in honor of like yeah. You can see here, I would rather go to the back because I might add some diagrams and stuff. If I were you, I would go to the back. Any blank page at the back of that booklet, I would add that instead. There's enough. I won't use those blank pages for anything else. I will read it to you just in case you can't read my writing. Karan is part of the basketball team. He is 162 centimeters tall with a z-score of -1. Aaron is 185 centimeters tall with a z-score of 2. What is the standard deviation of the heights? And what is the mean height of the team? I will also say this, whenever you feel a little bit overwhelmed with this unit, just remember what you know, right? You do know a lot, like you've shown it on the quiz with ACs and stuff like that. You do know a lot, so always go back to that, okay? And for example, if inverse norm right now, if you got it wrong, don't sweat it too much, right? Like just try to read it and see. That's a 1-800 anyways. All right. We're good? I would actually say questions like these, I would make a graph, just a little quick bell curve, right? So I would just go, okay, what's going on here? Z-scores, every height has a z-score associated with it. And I will also say that it happens to be a nice round z-score, a whole number, not always. But let's just put this down. We know at the middle we have a z-score of 0. Then we have -1 is right here. And that -1 has a height of 162 centimeters. So we know that Karan is below average when it comes to height. This is not Karan's actual height, just so you know. Okay? Don't go tell him. And then on the right side, you would have +1 here, and you have +2 here when it comes to z-scores. A z-score of 2 in this particular team, right, is associated with a height of 185 centimeters. Right, so they are all linked together. So when you find the standard deviation, you go upper minus lower. How many gaps are there between them? It's quite easy to see, right? 1, 2, 3. 3 gaps, right? So when I give you z-scores, you just have to be careful to come up with the correct number of gaps. Okay. 23 divided by 3 7 point, is that right? 7.67. And we are talking centimeters, right? Yeah, we're good. So that's my standard deviation. And now you have a choice. You cannot don't use this plus that divided by 2. You cannot use it. Because if you did this plus that divided by 2, you would find this value here. Instead, what you use is just either one of these values. In this case, if I take the 162 and add a standard deviation, right? If I add a standard deviation to it, I get to my mean, which is what they want, right? So my average here is 162 plus 7.67. That's it. And that is 169.67 centimeters. I will make a note of that. Note, in this case, we don't use upper, lower divided by 2. Okay? You can't in this case. That's only if I give you the 68, the 95, or the 99.7, where those values are equidistant from the middle, right, from the average. That's the only time you can do that. And by the way, this method can also be used with the other type of question, right? As soon as you have your standard deviation, you can just go jump until you get to the middle. Okay. All right, I'm going to call it quits here. However, hold on, don't pack yet, because you need to practice the first part we did today. At least, I would say at least 2 of them. Where's the homework for that one? Did I write over it? Oh, here. On page 25. On page 25, there's a bunch of questions that show whether or not data is normally distributed. And I will tell you, I will post answer keys to most of them. Okay, so 12 to 13, I have that key. 17, I have that key. The textbook, I guess you don't need a key for, right? So pick and choose what you want. If you want to start test reviewing, I will also post the key to this whole booklet, the review booklet, online.